Hey AP Computer Sciences, I'm going to do a quick video introduction to Unit 5 on class and object methods. We're going to start off by using and writing some of each of these, and the next unit we'll do a more in-depth exploration of class methods and kind of taking that to the next level. So what I'm going to do is I'm going to focus this video overview just on the key information slides, and then on one foldable, which we'll complete together in class, which has the main structure in the way I would like classes to be put together. So, classes and objects. So a class is just a category. An object is one example or one instance of a category. You can have more objects than classes, but you can never have more classes than objects. By the Java convention, all class identifiers start with an uppercase, and all object identifiers start with a lowercase. And you've seen the Grid World case study with me in Java before, but basically it's a visual way of representing different kinds of classes and objects of classes. So I won't belabor this, and I'll actually jump to the next slide. So we've got two different classes here. One is the bug objects, and you can see there are several instances of them. Each have their own location. And there are three rock objects, and again, they each have their own location on the grid. And this is just a visual example. Okay, so class methods are the same thing as static methods. It's just two different ways to referring it to it. And so the math class, which we use a lot in here, it contains both class methods and class attributes. Static methods are not called directly. An object, let me get that wrong. Static methods are called directly by using the name of the class. You don't have to create an object of a class. You don't have to instantiate an individual object of that class to use the static methods. One instance of that is the math.max method. That is a class method or a static method in the math class that we can use without ever instantiating class. Okay, just a quick overview. These are some of the different math methods that you may need to use. And then, of course, pi and e are the attributes we most likely use. Okay, so an object method. Object methods are non-static methods. So the word static will never appear in the header. That keyword static will never appear in the header of an object method. And object methods are really intended for situations where lots of copies of an object might be constructed. An object of the class must be instantiated to use the object methods. The object methods can never be called directly on their own. Okay. So let's compare data types and variables to classes and objects. So we've seen frequently number variables like an x, and the data type for that will be integer, int. However, when we're working with object methods, you've got the name of the class and then the name of the object. It can really be referred to that bank is the data type and Tom is the object of that class. Okay, and you've seen this before. Again, just like with integers, you can declare and instantiate them separately. You can declare and instantiate objects of a class separately, but the preferred method is the one-line method, just like this. Okay, now I want to take a second and jump over to Schoology. We're going to look at a class structure for a class in which you intend to have object methods, non-static methods. So typically we'll start your class with a class heading. Then you'll have private instance variables. Those are also referred to in computer science as PIVs. They are variables that can only be used internal to that class and they cannot be accessed from the outside of the class. After your PIVs, you have a constructor, and then you'll have a group of accessor methods, then you'll have a group of mutator methods, then you'll have a toString method, and that's your general structure of the class. Your class heading, private instance variables, constructor, accessor methods, mutator methods, and the toString method, in that order. This is the set of items that we'd expect to see in the class. We'll work together in class to fill in these definitions here, but I'd rather have you just look at the structure of this sample class. So this is the public class rectangle. Here are the private instance variables. They're both private. Maybe that's obvious, but I still wanted to state it. And then you've got the data type and then the name of the variable. So those are your private instance variables. And then we've got the constructor. Well, here we're creating an instance of that rectangle. And then we have an accessor method, or two. The get perimeter and get area. They actually access the value of that internal private instance variable and then make it available to other classes or other methods. Okay, then the mutator methods actually change the value of the private instance variables for that class. And then the toString method. We're going to spend a little bit more time on that together as a class, working on writing toStrings, and I'll actually give you some sample code. Just as a reminder, the toString method is a very special method that's inherited from the object class. Its purpose is to build and return a string that represents the class. It typically overrides what would by default belong to that class in the toString method. Okay, so we're going to hop back over to the slides. We're going to take a look at using the random class. Okay, so the random class contains object methods, which are useful in lots of programs. There's next double, next int, next set seed, long seed. This sets the seed of a random number generator using a single long seed, long being a data type. So an object of the random class must be constructed to use the object methods. The object methods can't be called directly themselves. So you always have to have an instance or an object of that class to be able to reach its methods. Okay, and so here is the syntax. So random, data type rand, name of the object, equals new random. So here we're basically saying we're going to use the object name random with the data type or the class name of capital R random. And then to get what we want in terms of those random number items, large is the largest integer you want, small is the smallest integer you want, range is large minus small plus 1. And so what we can do is generate a random next integer using the set range and the set small value. I'm going to have you run the code in this section. I'll have it loaded up in a zip file. Quick reminder, the random class and its methods are not used on the AP, but the random method of the math class will be. Okay, so math.random. Actually, I'm going to flip back and clarify that for you. The random class is not on the exam. The random method of the math class most certainly is. Okay. So here is the syntax for using math.random. You want to identify the three values, the largest integer you want, the smallest integer you want, and then the range. The range is your largest minus your smallest plus 1. So the general syntax is integer x, which is your random integer variable, is equal to the casted integer value of math.random times range plus small. So what actually happens is that math.random returns a real number between 0 and 0.9 repeating up to 16 places. When it's multiplied by the range, it returns a number between 0 and minus 1, similar to the next int method. Okay. So here is n times math.random ranges. So if n is 20, math.random returns the smallest value of 0. Math.random returns the largest value of 0.9999. Okay. So you already know how to use scanners. So I just want to touch on this briefly. So the scanner class is available for interactive program input from your users. The scanner class is a part of the util package. It's a utility. And keyboard input requires the scanner object is instantiated with the system.in parameter in this syntax. Scanner keyboard equals new scanner of system.in. Next line brings in strings. Next int brings in ints. Next double brings in doubles. Next line at char 0 or char 0 is used to enter char information. The methods next int and next double don't return the line return carriage feed from the buffer, but the next line method does. So a dummy string variable is often used to take care of that control feed. So string dummy equals input.nextLine. So what this does is it will take care of the discrepancies with that return character. I'm going to have you run the code for this section as well. Okay. Now the integer class. This isn't the small lowercase I integer like we have been using. This is the uppercase I. It's referred to as a wrapper class. So int and double are primitive or simple data types. Integer and double with capital letters are classes. They have attributes and methods that come with them. And int and double should be used for math calculations, but integer and double should be used when objects are required. And there are certain data structures that require objects. So we can't use the simple data types int when we're using items like an array list. Okay. So the capital I integer class wraps up int values. The double class with a capital D wraps up lowercase d doubles. And capital Boolean wraps up Boolean values. Okay, so before the end of class, I would like you to go ahead and run the code that is in the zip file for these sections, paying special attention to running and modifying the code around the line carriage feed characters. Which is in section let me give you the exact numbers for that. Okay, so you want to be looking at the programs 0623 down through 0628 to experiment with the line return feed characters and how they work and don't work well together. Okay, that's it for lecture for this unit. Go ahead and download the zip file of all of the yellow slide codes and pay some special focus to the line return characters. You'll need that for the lab and for the test. Have a good day.